Imagine looking down at a brightly lit city at night. You can see the streetlights, the neon signs, and the headlights of cars. Now imagine someone telling you that all those lights make up only 5% of the city's actual structure, and the rest is completely invisible. That is the exact situation we face when we look up at the night sky. Every star, planet, gas cloud, and living being we know accounts for just 5% of the cosmos. So how can scientists possibly map out the remaining 95% if our most advanced telescopes cannot see it? The invisible universe reveals itself through massive gravitational footprints. It leaves behind physical evidence of an epic, unseen cosmic tug-of-war. Look at this image of the Hubble Deep Field. It contains thousands of galaxies, representing a staggering amount of regular matter. Yet two unseen competitors are actively manipulating all of it: a hidden glue pulling everything together, and a mysterious rocket fuel blowing everything apart. To understand our own existence and the ultimate fate of the universe, we have to uncover the identities of these two dark forces dictating reality from the shadows. Think of a playground merry-go-round. If you spin it too fast, the people holding on will eventually lose their grip and fly off. Vera Rubin noticed galaxies act like overspun merry-go-rounds. In this spinning galaxy model, a graph reveals outer stars move far too fast for visible mass to hold them. To keep them from flying off, a massive, invisible halo must wrap around the galaxy. Physicists call this material dark matter. It makes up 27% of the universe. It does not emit, absorb, or reflect light, but it exerts a massive gravitational pull. We map where this invisible mass lives by observing a process called gravitational lensing. When light from a distant galaxy passes near a cluster of dark matter, the light bends and magnifies, similar to looking through the thick glass base of a wine goblet. Dark matter is the architectural scaffolding of reality. Without this hidden glue pulling gas and dust together, our Milky Way and the Earth itself could never have formed. If dark matter is constantly pulling things together, you would expect the universe to be shrinking. When you throw a ball into the air, gravity pulls on it. You expect it to slow down, stop, and fall back to the ground. Now imagine throwing that ball, and instead of falling, it suddenly rockets upwards into the sky, accelerating faster and faster. That is exactly what our universe is doing. In 1998, astronomers studied this image of a distant exploding star, known as a supernova. By measuring the light from these explosions, they realized the expansion of the universe wasn't slowing down, it was speeding up. The force driving this acceleration is known as dark energy. It acts as a repulsive, anti-gravity push, and it accounts for a staggering 68% of the universe. Decades before this discovery, Albert Einstein wrote a repulsive energy into his general theory of relativity to keep his model of the universe static. He later removed it, calling it his greatest blunder. Scientists believe he was accidentally right. This repulsive energy is a property of empty space itself. Dark energy is the supreme cosmic engine, actively overpowering the gravity of dark matter to stretch the fabric of space-time faster every second. This leaves scientists with a massive dilemma. What if the invisible glue and the invisible repellent are not two different things, but the exact same substance wearing different disguises? The dark fluid theory proposes exactly that. It suggests space is filled with a single cosmic liquid that possesses negative mass. When dark fluid flows near regular matter, it coagulates around the structure, creating the extra gravity we observe as dark matter. But in empty voids between galaxies, the fluid relaxes, acquiring a negative pressure that pushes outward as dark energy. Whether reality is ruled by two opposing forces or one shape-shifting dark fluid, this 95% enigma holds absolute power over how the universe will eventually die. The ultimate destiny of the cosmos depends entirely on which side wins the war: the cyan glue pulling inward or the magenta rocket fuel pushing outward. Right now, dark energy is winning by a landslide, driving galaxies apart at terrifying speeds. This leads to a scenario called the Big Freeze. Dark energy pushes galaxies so far apart that they slip beyond our observable horizon. Eventually, stars burn out, the night sky goes completely black, and the cosmos approaches absolute zero. An alternative, more violent scenario is the Big Rip. If dark energy's repulsive force increases over time, it will eventually become strong enough to tear apart stars, planets, and finally, individual atoms. It is a humbling reality check to realize that every historical event, every scientific discovery, and every star we've named applies to just 5% of this playground. Realizing we only know 5% of the universe is not a defeat. It proves we are just standing on the shore of a vast cosmic ocean, with the greatest mysteries in physics still waiting to be solved.